Chapter 8, 6 functions defined by tables and graphs. Now, this is an interesting section. This is more of a comprehension. This is really good for deeper meaning, understanding how things are related. So to understand what a function is and define a function by using tables and graphs. So a function is sort of like a linear equation. It's a relationship between two values or two unknowns, x and y typically. But we need to understand that there is one unique x has one unique y. So if we plug in 1 and we get 2, when we plug in 1 again later on in a week and a month to that same equation, we expect to still get 2. If we don't, then it's not considered a function. A function are written very, very interestingly. Functions are, let's show you an example of a function notation. So function notation is f of x equals 3x plus 4. That would be a function. It's very similar to y equals, it would be very similar to 3x plus 4. So where f of x is just a representation of y, x is still my x value. So if we had in a coordinate, you have x comma y, and that would be for this equation. If we had to write it in a coordinate, it would just be f of x comma, that's not true. It would be, it would be x comma f of x. I didn't mean to do that. It would be x comma f of x. Now that does not mean f times x. Very important. I think we did function notation a little bit earlier in the chapters. So that's not f times x. That just says the function of x because that's the variable we're dealing with. But it means the same thing. This is still a slope. This is still a y-intercept. This is our input. This is our output. So that's really where they start using input, output. This is independent. This is dependent. This is a dependent variable, and it's dependent because it depends on what the x is. The nice thing about this is if we want to define f of 3, meaning my x value is 3, we would plug in 3 for x, and then we get f of 3 equals 9 plus 4, or f of 3 equals 13. So when x, I don't know why I put x there. So when we put in an x value of 3, we get a y value of 13. So we can see what we're plugging in because that's what went in for the x value. So it's a nice notation, and it allows us to differentiate equations. If we had 4 equations, y equals, we wouldn't know which one is which. You have y equals 3x plus 4, y equals negative 8 minus 11. How do you distinguish between those? Well, function notation lets us use variables, f of x or g of x, so we can differentiate them with that first variable. So we can say, oh, f of x, that's that function. G of x, oh, that's the other function. So just things to keep in mind. So it's, oh, and domain and range, sorry. So so we have x is x, f of x is y. We also have, I think I said input. That's our output. It is our independent and our dependent. And then the last one is domain, goes in for the x, and range goes in for the y or the f of x. So this is going to produce our range. This is our domain. Domain is our input. Range is our output. So state the domain and range of the function shown by the table. Then give the correspondence as a set of ordered pairs. So this is going to be my domain. This is going to be my range. This is going to be my x. This is going to be technically my y or my f of x, however you want to notate it. That's my input. This is my output. So my domain is each of these unique pieces, each of these data. Each piece of data, this is my output, and then we see, then give the correspondence as a set of ordered pairs. So notice that we have our x and then our f of x or our y. So you have the input, the output. Okay, so the domain, and we write it in solution set, is antelope, cheetah, greyhound, racehorse, and rabbit. Silly rabbit. Tricks are for kids. So this is our domain. Our range is going to equal also solution set 60, 70, 40, 50, 18. Now let me see if they put it in numerical order. They do. So notice it does not, there is no correlation. It's not alphabetical order in our domain, but our range is alphabetical or numerical order. So we will erase that and we will rewrite that correctly. So we're going to have 18, we're going to have 40, we're going to have 50, we're going to have 60, and 70. And now we're going to write the ordered pairs. Is that in a solution set too? That is in a solution set with coordinates. So we're going to have solution set and coordinates, and we're going to have antelope, comma, 60, close. We're going to have cheetah, don't be a cheetah, 70, close the parentheses, coordinate, and then we'll have greyhound, and greyhound is 40. Then we'll have racehorse, is 50, and then we will have rabbit, which is 18. And maximum speed, good. So we got to do this silly activity. So let's do domain. Do they use an equal sign? Let's see if they use an equal sign. Yes, they do. Good. All right. That's what I had done. Domain equals solution set, clock, radio, toaster, TV, blender, and cookbook. Close solution set. Our range now will be in numerical order, so we'll do 19, we'll do 25, we'll do 28, we'll do 37, 46, and 55. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And did they have a specific name for that? No, they just have them in a solution set though. And then they have clock, comma, 37. They have radio, comma, 28. They have toaster. Yep, this is real fun. 46. It's good practice. I know it may not seem like we're going to use this skill very much in Algebra 1, but parentheses because we want it as a coordinate, blender, but we do it, and we do it properly, and we do it technically correct. We want to do cookbook. All right, cookbook, comma, 55, and close it. So yeah, may not seem very relevant. So domain is always, and the way I remember which one comes first, domain is D, range is R. So I wonder if we would do the domain in numerical order. That'd be interesting to see. Let's take a gander at the answer key for, what is this, 8-6, because I want to be correct. It's loading it. Let's change the look. So let's look at the answer graphs of this answer key. Answers at the back of the answer key. I have no idea where. Oh, do I have it on the top there? No. Let's look at this. Worksheets. Worksheets. Absolute values. Well, it's 8. Would it be in there? Chapter review. Pre-assess answer key. Practice. Pre-assessment. Nope. I was just hoping that, what was it, 8-6? No, that's notes. So I just didn't know where additional solutions were. I kind of sometimes put additional solutions somewhere, sometimes worksheets. Oh, additional answers. All right, let's see. Can I get it? Maybe. Did I have it? I can't tell what worksheet that is. Chapter 8. We'll download 5. Can we download 5 for me, please? From the that's 176. God knows what page we're on. Well, let's keep going back this way. Nope. Let's go this way then. Come on. No. A lot of additional answers. Nope. Not my additional answers. Oh, well. Oh, that kind of looks like it's the next one. Come on, baby. Come on, additional answer. Hold on, hold on. Oh, there it is. Yes. Paid off. Let's go. Ah, they do. So it was worth our effort to ensure that we did it correctly. So domain. Oh, the years were already in numerical order. 1965, 1970. Whoops. 1975. Bit of a waste of time. Sorry. 1980 and 1985 when I graduated high school equals range. Graduated high school in 1985, baby. Yep, that's also in numerical order already, so we didn't have to check anything. But it clearly states that we are going to do some graphs in a little bit, so that's going to be interesting. And now let's do the coordinates. So 1965, comma 1000. We have 1970. I think I was in 8th grade in 1970. 1500. 1970. I think I was in 7th grade in 1970. I think I graduated 8th grade in 71. No, that wouldn't make any sense. I wouldn't have graduated. I think it was 81 that I graduated. I was a freshman. So I graduated 8th grade in 81. 1975, sorry for the history lesson. 1980. 2250. And the last 1985, comma 2500. Close the parentheses, close that. All right, draw a bar graph. So when we draw bar graphs, we're going to choose a horizontal axis. So that's going to be my horizontal axis, tends to be my x-axis. That's my x items. And then my list the members of the range along the vertical axis. So and then for each member of the domain, draw a vertical bar to represent the corresponding value of the range of the function. Start the scale of the bars at 0 so that the relative lengths are correct. So you want increments that are consistent. This is going to be my x. This is going to be my technically f of x or y. So we saw that in the first example. Northern, central, eastern, western, southern, and then we saw the values, and they are approximate. So yes, here we go again. So let's draw, and now we're going to have antelope, we're going to have cheetah, we're going to have greyhound. Now let's see our artistic skills. Then we're going to have racehorse. And we're going to have rabbit. And this is going to be 0. We got to go up to 70. So we'll go by increments of 10, 10, 20, 30, 40, 50, 60, 70. So that's 70, 60, 50, 40, 30, 20, 10. Antelope was 60. So antelope's going to look like that. And we can, cheetah is going to be 70. So that's going to go up to the 70 mark. Scribble it in. Thank goodness I have this. Greyhound is 40. So greyhound's going to be about there. Drawing down. And I guess you could do lines that go across here in order for you to be able to measure it. We're going to sort of understand racehorse is 50. So racehorse is going to be something like this. But we saw how they had temporary lines, and rabbit is 18, so not at 20, kind of close. And so we could have done, let's do some dotted lines, and let's do it thinner. So you could have lines that go, oh, I don't need it green. Let's make it black. So it looks like the graph. Make it black. Those should still be in. And we can do this. So 50, 40. Now you see that they're kind of off from what I had drawn, but you get the picture that we can utilize that. And so, maybe we move that graph down a little bit so it reaches the 60. Antelope's supposed to be at 60. Cheetah's at 70. Greyhound's at 40. Kind of there. Racehorse is probably my only one. So instead of messing it up, we can just erase. Yes. Look at us. And rabbit should be a little bit below the 20 mark. Hey, that looks pretty good. I like that. So does it have a title? I think you have to have a title. No title. Okay. Yeah, nice. That's my creative side, people. Okay, same thing. Let's move this up a little bit. Move you up a little bit so we have some space. We have this. We have clock. That's going to be 0. We have radio. We have toaster. We have TV. We have blender. And we have cookbook. Let's move you all over a little bit. Cookbook. Well, yeah, let's do, so our biggest is 55, so 10, 20, 30, 40, 50, 60. I'm going to draw my line first this time. Then I will know that I am on the right cue. Okay, so let's do clock. Clock is 37, so 10, 20, 10, 20, 30, 40, 50, 60. 37, so 37 is going to be something like this. Boom, boom. Color in. Radio 28, not at 30. Much easier. Look at that. We know how. Toaster 46, halfway to 50. We like making charts. Charts are a nice way to show relative information. TV 19, so not at the 20, close to it. Blender is 25, halfway between 20 and 30. And cookbook is 55, halfway between 60. Whoa, that was a big one. 60 and 50. Good. Easy peasy, lemon squeezy. Okay. This is interesting. So let's do the years. That's actually not bad. That's relatively simple. We have 1965, 1970, 1975, 1980, 1985. Now, we could do this and sort of, well, you can just go by thousands. So 1,000, 2,000, 3,000. That would be the easiest way, depending on how specific do you want to get your information. And then if you want, you can put little hash marks in there. You can show where, and let's do, yeah, that's 3,000. So you can do another one to show half of it, which is 1,500. You can show half, which is 500. So, and still label it 3,000, 2,000, 1,000. And you don't have to label the 500s, but you know what that is. So 1965 is going to be 1,000. 1,700 is going to be 1,500, so that's where it just came into play. That was a nice reference point. 1975 is 2,000, so don't be afraid to do that. That is okay. 1980 is 22, so that is going to be halfway between 2,000 and 2,500, and that is 2,500. So this one will go to that mark. So nice way of doing that problem. Draw a broken line graph from function in the table, monthly car sales. So instead of doing bar graphs, we just make dots at those locations. Still quite easy, really friendly, relatively simple to be able to look and see where your graphs are. We're still going to draw. We're still going to do this. We're still going to list April. But this time, yeah, if we look at that, let's look at that more closely. So this time it goes on that. And if you want an increment, we'll increment in between. That's not a bad thing. So this time, when we have this raised, this time we have a line for the April, and then the May, the June, the July, the August, and the September. So, and then there's kind of increments in between them. Well, that was not a healthy one. So you have these somewhat increments between. Technically, there's an increment in between that. Can I move that? That'll be interesting to see if I can. Oh, yeah. And I'll just erase that April real quick because I want the April to go underneath it. But I want one more line there. I want one more chunk. I'm still going to move this a little bit further over. And extend that. And then we have increments. Ooh, okay. We got to go up to 85. So we can go by 20s. So 20, 40, 60, 80. So that's 80, that's 60, 40, 20. This is, did they start on the first increment? They did. So this is April. This is May. This is June. This is July. This is August. This is September. And now we want to do going across, going across, going across, going across. Technically, we can do that 10 one right there, the 31 right there, the 51 right there, the 70 right there. And now we've got nice little grid. So now we're going to make dots. So April is 60, we make a dot. May is 50, we make a dot. June is 78, that's up here-ish. June is 85. Whoops. June is 85. That's going to be about here. June, July is 78. So July is 78. August is 40. And September is 52. 52 is going to be just above the 50. Now we're going to connect said dots. Oh, do we go from 0? No, we just start on our first data point. Oh, shoot. I need them bigger. So this will be from here to here, from here to here, from here. I thought I just saw an ant on my body. Sorry. From here to here, from here to here, and from this point to this point. That looks nice. That's a nice graph. I'm very happy with that. Okay. This is going to be my X. This is going to be my X or my domain. This is going to be my Y or my f of X, which will be my range. And I'm doing a graph. We have 1983. So I'm going to label this 83, 84, 85, 86, 87, and 88. I don't mind moving those over a little bit. There you go. Let's make dots. Get back to my dots and dashes on those years. It's just the easiest way to do it, right? I mean, for graphing purposes on a computer or a sheet, so we can do the intermediate ones for just locations. And I'll put a little one in there. And now let's look at our profit. It's going to be on our y-axis. So we're going to go 200 to 350. You can do this. Do you know that you can do this? Watch this. You can use this symbol. You can go. So that means this is 0. You can label this 0, and then you can do your first increment at 200. And you can say, hey, I'm just scrunching this graph up. So this is 200. And then we can go to We can go 220, 240, 260, 280, 300, 320, 340, 360. So that's a nice way. And then we don't even have to do this. We could go 320, and we can go 200. We can go 240. We can do 260. That's 80. Whoops, did I mess up? 200, 20, 40. Oh, that's 60, 80. 80, sorry. That's 80. 300, 320, 340, 360. So you can also do that. That's an interesting technique in order to get the values in and make a chart that is can fit and represent the data. It's not the best way to do it, but I just wanted to show you a different way. Now, which one's a little goofy? That one's a little bit goofy. Can I move you just a little bit? Thank you. Let's do some points. We have data points 1983. We can do boop, 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 meaning those are years. 1983 is 200, so 83, 200 would be there. 84 is 215, so 84 is 215. It's going to be something like there. 85, 236. That's going to be somewhere right there. 86 is 270. That's like right here. 87 is going to be 300, which we know was right here. And that's 350, which is in between 40 and 60. Okay, let's connect the dots. Nope. Gotta go back. Gotta go back to my lines. Connecting dots. Connecting dots on your graph. How many more? How many more? 2 more. Draw a broken line graph for the function shown in each table. July 16th. Oh, July 16th is my birthday. I'm going to be 57. Will I look back at this video and go, oh my goodness, I was 57 at that time? We got that. We're going to make July. That's really big. Let's make that line a little bit less so we can write July, August, September, October, November, and December. And then we can go up to 30, 40, 40. So 10, 20, 30, 40, 50. 50. That's 0, 10, 20, 30, 40. Let's draw some lines. Let's draw some lines. 55 is going to be there. 45 is going to be there. 40 is going to be there. 35, 30, 25, 20, 15, 10, 5, July. Let's do one between July. Let's do August. Between August, September, September. Between September and October, October. Between October and November. Between November and December. Boom, baby. Hi, how are you? Okay, love it. I'm having burgers for dinner. July 16th, this is hours of overtime, so we have, let's do this. So 16 hours for July, that's 15 is there. August is 30. I hope they go up and down. September is 22, yes. 22. October is 28, closer to here. November is 34, way up here. 35, that's 34. And December is 43. 43, well, that's just so you can buy Christmas presents. So connect, 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 connect. I'm surprised that many overtime hours in the summer. Typically people want to take a vacation. How fun is this? This is pretty fun though. Oh, we could, oh, look at, yeah, we could use straight lines to make our graphs. That wouldn't be that wouldn't be the worst thing. 60, 65, 70, 75, 80, 85. Ooh, all right, well, technically, I think we're going to go 100, 200, 300, 400. And let's draw some lines. 400, 350, 300. I will tell you that having this tablet makes it really much easier. I mean, it's kind of nice. It is a drawing tablet. 60, we'll put one in between, 65. I guess it streamlines the activity, the drawing. So this is very apropos. Okay, let's start putting some data in there. 60 was 88. $88 is probably right around there. 65 was 122. So that's underneath that one. 70 was 190. That's right under there. 75 was 289. That's probably right about there. 80 was 371. That's 70. That's 50, 75, and 386. So right there. Connect them. And nice job. There you go. That is functions. What do we call that? We call that functions defined by tables and graphs. Don't know how much you're going to use it. I guess actually somebody told me they did some graphing, some graph stuff. So hopefully you were prepared for it and you were able to answer the questions. Good luck.